What's up, and welcome back to the lab. Today is going to be an extremely interesting possible repair/revival video. These two, they were packaged incredibly here. Very, very nice. Thank you very much. Seller was packaged just extremely well. Both of these are two Fluke 77 Series 1s from a New York estate sale where they were found. I guess if it's an estate sale, I guess the guy died. They do look absolutely fucking disgusting here. Like, look at these. Looks like they've been underwater for a very long amount of time here. The seller was able to power up, I believe it was the 10 amp unfused one. They're both 77 Series 1s. There's two major revisions of that, one with an unfused 10 amp section and one with a fused 10 amp section. Which is actually interesting because my very first multimeter was actually a used Fluke 77 Series 1 with an unfused 10 amp section, and that served me incredibly well. I still have it, of course, but mine did not have the stand, and both of these do in varying conditions. The seller was very cool. They refused to part these out and ensured that everything stayed with the specific one. So like, here was the probes that were found with the unfused 77. They are both Fluke probes, but they are mix-matched. One of this series that has been severely shortened due to an arc, I guess, that happened. And this is a straight-through shrouded banana with some varying levels of damage here as well. And then our other one is what looks to be just a standard Fluke TL75 from like the 80s. 15,000 volt max, says Fluke. Both of them do say Fluke. I'm not sure the exact model that this one is. I'm pretty sure this disconnects, but it is absolutely not on these. So mix-matched and half destroyed. These belong to this 77. I'll show you some pictures now, just while I'm doing this voiceover or whatever, some pictures of them. They have some pretty severe rust damage inside. The range switches feel pretty bad. We were only able to power up... The seller was able to power up the one with absolutely horrid 9-volt battery connectors. He was not able to power up this one because it is missing the clips or on one of those connectors itself. So that's interesting. I would think this one we'd have a better chance getting this one to work than this absolutely horrific looking one here. But that one did power up for the seller. We'll see if it does for us, and we'll see if we can resurrect both of these. So essentially, this one has some nice but pretty severely bent leads. I'm just going to disconnect. We're not going to be using these. I mean, well, we'll keep them with each one. I'll remember which one they go with. I'm just saying we'll start doing some other... Look at the back side of this. Looks really clean. Not too bad. And then you look at the top, and oh my god, what happened? What freaking happened? Was this underwater? Right, like, anyway, these are TL75s, and they're okay, aside from being pretty severely bent, as you can see. That is not a happy probe. We'll see if we can bend them back, clean them up, and see what we can do. And also, very interestingly, I don't know if this was found with these units, like at the same estate sale, or if the seller just included this in the hopes that these would be repaired. You definitely sold them to the right person. We're going to get both of these working and caled. It'll be interesting because what I'm going to do is just fix both of them. Hopefully, anyway. We don't know if the one that didn't power on, we don't know if the main chipset's good or not. But fairly hopeful. I mean, after this guy here, after this horrific one in the last video, I'm pretty confident we'll get these, up and running. So anyway, this was included. Just a nice little old, is that 80s? I haven't seen one with a blue sort of leatherette, backing there. That is quite interesting. We can, of course, unrivet this. I believe this is the snap that's missing on our 77 Series 1 fused, and try and rivet that one back on. But they're both pretty severely rusted off, and I do have some replacement actual board mount connectors. Not exactly sure which ones they were. I do know that they would be manufactured by Keystone, and we do have some here from Mauser. So for instance, there's the Keystone 500 series, like the 594s, 595s, and then there's also the 600 series, 636, 635. They're a little bit shorter, and I do have both of those. So in other words, I believe the original battery terminals that look like this here, I believe it is going to be these, which are the Keystone 500 series, Keystone 594 and the Keystone 593. 594 is the negative, and the 593 is the positive. Exposed around part, 594, tinier snap, 593. So essentially, I'm pretty sure it's going to be these. The height on these are a little bit shorter on the 600 series. So the 636 is the larger connector, and the 635 is the shorter, or more so small snap there. I don't think it's going to be these, but we do have them just in case here. I'm pretty confident that it's these that we're going to use. So we got them on the bench here. We'll take them apart and see, but we do know that the seller was able to power this horrific one on. So we'll see. We do have our new snaps there, which you'll see. It's probably better to just replace them, especially if I have them. I do like that little that little 9-volt connector was included. I don't know if we want to use that or not. That was probably, it depends. Do we want to help a ghost move on or something by using the parts that they were going to fix their meters with? Maybe, but it's not going to fix both, and we're definitely going to have to replace the connectors in this one. Like, this one's missing the snap. We could try and rivet it. I don't know. But this one's so far gone that we're probably going to have to replace a lot of stuff regarding those connectors here. So essentially, if we're going to have to do that anyway, I'd rather just keep that. I like the gesture there. I will keep that. Maybe we'll use it to repair something else, or something in the future that needs that specific blue type 80s connector. If not, let's just repair this with OEM parts here, and yeah, that's about it. So anyway, let's have a look first at the less disgusting one. So this is a 77 Series 1 fused, and we got just horrific, I don't know, is that mold? Is that whatever on our rubber case here? They both do have the cases, and this one's stand is in fairly good condition here. Not too bad. Quite clean under there. But overall it is very dirty here. It's not hard to know which one of these goes to which, so I'll just set this aside for now. Here is the unit itself. It is not so dirty. It's fairly clean. The range switch feels okay. Doesn't feel too bad. The range switch on this one feels... You could probably feel that through the screen. It feels bad. Really bad. That's the problem. And it is just, we've got some gouging to the face, or the silk screen, whatever that is there. This visible, like that's I don't know, scratched off as well. We've got horrific just coating of, I don't even know what on this case here, as if it's been like waterlogged. And the inside certainly looks like that. We'll show them in a second here. We do have the pictures of the seller as well. But just look at this. This is one of the most filthy, disgusting Fluke 77. Like, let me block some of the light there so you can just see how horrific this actually is. Like, look at that. It's bad. Ugh. But it does have a stand. Wow, my god, and look at that under there. Just horrific. Let's see what we can do. Hopefully clean this up a bit, but oh my. Probably just gonna soak this in a freaking bucket with dish detergent and try scrubbing it or something. I don't really know. Okay, so let's check their serials and stuff. So first here is a Fluke 77 Series 1 fused in pretty nice condition, aside from the absolute disgusting whatever happened to its case there. And serial number 4699018. And then we have the just horrific 77 Series 1 unfused, like was my first one. I'll show that in a second once I go get it here. And this is serial number. Look at how rusty the serial number is. That's plastic. How could that even rust? How? Definitely water damage, I think. This is serial 427-30557. So 42 versus 469. Yeah, okay. But let me go grab my good 77, my first meter. Okay, I'm back with my classic pencil-cased meter storage. This is my 77-1, which was my first DMM, and it's in pretty nice condition, just some generic leads here, as I think whatever came with it, or whatever I stole and put back. It never had original Fluke leads, is what I'm saying. So it would be nice to steal some from some period correct Fluke leads, which I will, from a different one here. Oh, I was gonna say, should we use this Necrode meter to fix these? Fluke 70 series, Fluke 70 series. But I do have a 70 series 1 here that operates just fine. And is nice. Darn. But also this one, Tom Berg was the original owner, apparently. I couldn't get that off fully. This one here, Tom Bird? Maybe it's Bird, not... Okay. Anyway, don't have the stand. So, darn. I am not going to steal the stand from one of these, or the probes from one of these. These belong together. But I will steal one from a different one to give myself a stand here, because this is my personal 77, and I want it complete. Mine has this little warranty data thing there, and is serial number 412-10021. So mine is actually a bit older than even theirs here, which is 427. Mine's 412. It's been an incredibly nice and reliable meter for me. Even though it doesn't have category ratings and is unfused, it's literally never let me down. It's a great little meter. Let's dig into these freaking abominations and see what we can do. Battery terminals are basically just not even existing in this dimension anymore. And let's see. Whoa, there we go. Oh my god, yeah, you can see that. Look at that. That is some severe damage to those terminals. Hopefully the rust hasn't gotten, like, look, it's on our current shunt here as well. We're gonna have to clean that up and see what we can do, but look at that. That is horrific. Those are supposed to be silver. And as you can see, some like differences here. 77 Series 1 unfused has this metal shielding on our precision resistor network there, and just some bent over metal shielding like this. We do not have one of those plastic covers, which the later Series 1s did. And look, even, wow, we can even see a lot of that rust here on our faceplate. Oh my, even our little, oh, that's just gone. Oh, that's gone. Well, darn. Gonna have to clean that up and put a piece of foam tape there or something, because that is, it's just disintegrated. I don't know if, mine isn't that bad, so I think that's due to the water damage or something. I don't know how he even powered these up with this level of corrosion here. Like, that's just insanity. There's like no good parts of that left. Oh my god, I just cracked that with my hand. Well, could we maybe take these off, evaporust them, and then try and rivet on the two new connections for the other one, or just rivet on one for this one? I would rather just replace these entirely. You should never power on a board like this with this much rust and just everywhere. I am going to, however, because the seller did. So what we're going to do is use a bench supply. We're going to limit our current way down so that we don't kill everything. Bump it over into DC volts mode. Oh my gosh, there we go. Okay. So it powered up, and we're pulling nothing that our BK1670A supply can see, so we don't have any current that's going crazy or anything here. The piezo didn't work. Probably destroyed by the water damage or something, so that's cool. For the spirit of things, let's use the wonky mismatched leads here. Let's take our DMM Check Plus, revision 8. And we're just going to see here if this is anywhere near on. Oh, look at that, within a count. 4.99 for a 0.5% class meter. That is well within spec. How is this? Look at it. How? Alright, that's impressive. Okay, that's cool. Let's check with our Necrode. Now, piezo working. Let's check to see this main fuse here. Is this bad? Yes. Yes, it is. So that is not going to measure current. So that fuse is bad. Now, in the older Flukes, they did also have a spare fuse here in the body. And that spare fuse is fine. I'm not going to use that though. Let's treat it. Let's treat this absolute survivor to a brand new Fluke, totally Fluke and not actually, Busman 630 milliamp 250 volt fuse. Put in a nice new one here. There we go. Cool, brand new fuse. So we know it's working in DC voltage. Let's put it back to AC voltage. So now we should be in AC voltage. Let's switch this over to AC. It's a non-true RMS meter, so this should display something along the lines of 5.55. 5.54, holy hell, it's on. Okay. That's within a count. It's going to be hard to see here. Let me see if I can, prop this up while maintaining this position here. Yeah, look at that. Within spec. Next thing we should check is the resistance, even while looking like this. Its input protection isn't blown because we got a nice overrange here, or overload, and we can zero that. These are approximately 1 ohm. They're pretty filthy. I guess that's believable for now. Let's go ahead and test. These are so bent and arced and everything. Give me a moment here and we'll test our precision resistors. Should be 100 ohm. A little high, 100.8. But these are like 1 ohm itself. Forgot about that. They are like 0.8 itself. Okay, well then that's perfect, actually. Yeah, it's 1 ohm high, within a count. Perfect, 10K, should be 100K. And that's 100K, holy damn, that's on. Alright, so ohms range side, input protection checking just fine. Calibration, well within spec still, even without any adjustments. Next, what we'll want to do is test diode test mode. Let's just make it test a diode like this. We shouldn't see anything. We don't. Like this, we should. Yeah, that's about correct for that one. Okay, let's see what our voltage output is in diode test mode. 2.51 volts. Sounds about right. Now we'll go over and test the milliamp range next. So, one down again. Oh, that feels so bad. We gotta clean the whole range switch, take that apart, do something. Okay, we are in AC. This should see what, it's not a true RMS meter, so this 1 milliamp with the frequency here should show up as 1.11. 1.10, that is one count out, but not bad, and we got a lot of rust on the shunt there, so that's amazing, to be honest. Completely amazing. That's still within spec. Let's switch this back over to DC. This should be 1 milliamp DC. So now we're in DC milliamp. This should show as 1 milliamp. 0.99 within spec, 1 count. Oh, 1. Perfect. Yeah, look at that. 1 milliamp. Nice. Well, let's just set this one aside for now and dig into the other one, basically. So we do know that this one works totally fine, is disgusting, and needs new terminals, because those are literally cracking into pieces. Insert Papa Roach. this unit, which is a lot cleaner. So this is still a 77 Series 1, however you can see that it has this plastic shroud instead of the bent metal, like this. Fairly similar, that could be a good thumbnail maybe. But you see we do have a fused 10 amp section here, and that fuse, by the way, is a Limitron fast acting KTK 15. So this one is a lot nicer inside. We don't have to really worry about too much corrosion. A little bit there, we can brush that off, that'll be fine. I don't see anything toasty. We look good. But as you can see, we are missing the actual connector that snaps into the battery there. It's just gone. So the rivet must have failed and it must have fallen out. That could be why they included that nice new one, but I'm not going to rivet that. We're just going to take this off and put a new one on, because we're going to have to put new ones into this anyway. Because that's just, oh my. The very first thing we're going to do is use our Necrode Fluke here to test the fuses. Uh-oh. Uh-oh. Oh no. This fuse is gone. What about the milliamp range? This fuse is also gone. Shit. Okay, well I have replacements of these. Let's grab another one. Oh, and also let's see, is the one that the factory spare here, is this still okay? Yep, that's still okay. So let's get one of these. Down to 3. Woo. Yep, this is a fast-acting Limitron, fast-acting KTK 15. We do have some 15 amp ones here. These are the type with like the nipple. These are Gould Chamut. I don't know who makes that. They're made in Mexico. Definitely not ideal. And we're going to need to leave this out to get to this screw anyway, so I'm not going to put this in just yet here. Put in the new one here, which we'll use for testing. Click. And let's see here. Let's put it into voltage AC for just our first boot here. Try powering it up. This one he didn't power up, interestingly, even though it looks a lot better. Well, that powers up fine, but look, it's got one of these, I've only seen this once before where the screen is not black. It's very ambery color. Like, look at that. Isn't that weird? How strange. I have one 73 Series 1 that looks like this as well, with not black liquid crystal. It's like very coppery colored. We have no abnormal current drawn, we're looking good. Let's try and read AC 120.5, true RMS reading over on our other 120.8, not bad. Not bad at all. Skip, and then we'll be in DC mode. And this range switch feels very good. Let's see if this thing is still in cal. And it is 4.99 within a count. Look at that. That is impressive. Next range, we'll go over to ohms. Let's steal Ace's TL75 modern ones. Okay, let's see if we can short. We can, all the way down to 0.2 to 0.1. These are nice probes. So use the amp probe to prop it there. Okay, now let's see. Check calibration on its ohms ranges here. This should be 100 ohm. Oh, bang on. This should be 1000. Oh my. This should be 10,000. Holy shit. How? This should be 100,000. Oh my goodness. Well, that one is hilariously on point. Cool. At least there's not too much to do on this one, just a light brushing to clean up that, but no real rust damage. We'll need to replace the terminals though. Let's check our diode test mode. Good Fluke here to test this one. Should be nothing. This side should be 5, 1. Okay. I can hear that. It's making noise, but barely. Like, oh. Okay, if we apply any amount of pressure, like at all, to the board, then our piezo starts working. So it's just a connection issue with the piezo. Piezo itself is working just fine. Let's test a diode here. Like this, we shouldn't see anything. Don't see anything. Like this, we should. Yeah. Okay. Oh yeah, we didn't actually test AC voltage, did we? With this. So let's go back and do that. So this should be 5.55-ish, because not true RMS. 5.53. That's within. Okay, now this should be 1.11 milliamp ideally. We're reading 1.110, or just 1.10 in other words. That is within spec. We are good. Let's compare, see if we got the right parts here. 2 of those. Not a sponsor, but please. 2 of those. So let's compare here. Yeah, I think that's correct. So the Keystone 500 series, I think, is going to be the correct thing here. So what we're going to do here is take this one apart, use our Hacko to suck these out, and get these installed, clean the board up, reassemble it. The main part of this one here is going to be that disgusting case. But we'll clean that up as well and see what we can do. So in order to take the board off, you have to remove this, and this is under tension from a spring beneath it, so keep that in mind here. That is under tension here. The board should just lift off, like this. And with the board removed, we should have ample access to get these out from here. Like, those do not look the best, so we'll have to see. This is just what they look like from this era. They don't look the best. Some bubbling and stuff, but it's just how they are. They're operating fine. This is the same type of piezo, using the same type of strap with these little conductive rubber bits there. Do not lose your spring here. Let's work on getting these out. Put our DMM check back up there for now. And we'll use our new favorite tool, anyone in the repair industry. Ooh, Hacko FR301. So, what we're going to do is go ahead and power it on, and leave it, probably setting 2, maybe 3, 2. I don't want to rip these pads off. I got that unsoldered, however, they are bent tabs, so that's not coming out. You know, I wouldn't mind just cutting this off, to be honest. Like, I don't want to damage the traces on the board. Let's go in here with the Hacko CHP 170s here. Okay, then we'll have to clean up and try and get them out of there. That would look pretty good. So I think we got the right thing. I don't know if we want to replace this terminal, to be honest. Should we keep the original terminal? There's really no reason to replace it. They're the same damn terminal. I think we should just leave it. It's in really nice condition. What do you think? Rip it out just to replace it with the same exact Keystone terminal? Yeah, those are the same darn terminal. We do not need to replace the other one. Let's not replace it. It has no corrosion at all and is perfect still. Just gonna flux up the board. Okay, we've got those all cleaned up here. Looking ready to add our connector. We'll clean the flux off when we're done. nicely. Like I said, we'll spray off the flux and stuff and clean that. And let's give it a special treat, shall we? Let's give it a brand new battery. So 9.73 on a brand new pack of Energizer Industrials. Let's see if it works. And it boots. Yay! These were so annoying to take the batteries out because it's like, oh no, look, I cracked them off. Just kidding, they're split MOFs. They're supposed to be like that. When we dive into this, that fuse that we just put in, we need to take out. Because it's the only one that does that. Let's open this up. Wow, yeah, look how dirty the inside is here. We're going to have to clean this up. Ugh, don't want to turn this over. What do you think? Horrible corrosion? Not bad. So up close at this board. Looks like this here. Interesting, but yeah. So what we're gonna do, should I just try and clip these off? Oh, that just clipped right through, I didn't even notice. Wow, these are made out of nothing. Okay. Alright. It should snap here. Don't want to lift a trace, but it should snap. There we go. Get that one out. Should be holding this the other way. I don't want any particles to go into our range switch. Okay. Got those two off. I'm going to have to clean up a lot of this rust and contaminants. We'll try and suck most of these out and get new terminals in. We got a lot of damage here. It is not pretty. That's just a lot of crap. Okay, well, I mean, that's as good as it's gonna get. We've cleaned up our traces quite nicely here. They are ready for new solder and the connections. We do have some rust on this side of the board we still need to get off, and a lot of rust on this side. We also cleaned them up here. There is just a ever so tiny piece on the right hand side here that is damaged on that trace. It's not taking solder properly. I don't know if you can see that. There is still a bit there, like there's enough. See that there? A tiny margin that's rusty. So what we're going to do is we're going to CRC bath everything, scrub this up, and I'll be back once we do that. Okay, welcome back. We've got our terminals all ready here, but we've got a lot of flux on there, and that's not really the problem. The rust is the problem, so we're going to try and get that off. We're going to use a nylon brush here to scrub with some contact cleaner. This is CRC QD. You could also just use straight isopropyl alcohol, and or IPA. That works just fine as well. That chip right there or that plastic is not just plastic. That is the literal Fluke chip from behind. I don't want anything to sort of get on the legs internally, so what I'm going to do is basically just kind of cover that, and we'll spray it down like this here and see if we can get off. That's better, but there's still some there on the top of the solder mask, and then up here we need to get taken care of. Yeah, that's pretty good. slow, but it's happening. Now, before we turn this on, we're going to have to get all these little whiskers out of this so it doesn't short anything. All these steel wool whiskers, we're going to have to blow this out. Pretty good silk screening on this, solder mask. It's cleaning up pretty darn well. Look at that. just a terribly slow process.
Okay, here we are. There's the Fluke 77 Series 1 unfused with the connections all ready to be installed for our terminals, and we got all of the rust removed from the board here. We've also, as you can see, cleaned the range switch, and it is nice and shiny now. It is completely not aligned properly, so we'll have to look at the other one to make sure it's in the off position or whatever position we left the case on. So we'll do that. But first thing that we'll want to do here is go ahead and just give you a good look at our connections. So those look beautiful up there and should be perfectly suited to installing everything. Managed to get all the sort of rust from this area removed. Just clean out our case, which is horrible. Okay, there. Now we got the inside all nice and cleaned, de-rusted, as you can see. Let's take a look at our brand new terminals. A little bit different, a little bit better condition. Luckily that one's pretty tight, so it's gonna like hold itself here in the right position while we do this. Okay, here we are with our unfused model. We got the flux residue cleaned off. We've got our terminals nice and installed here, aligned pretty well. Let me see if I can get that straight for you to see. Yeah, see? Not bad. And their soldering is pretty good, as you can see here. Looking pretty factory, aside from the bend, because, you know, we want it sort of easy to remove for the next person 40-something years from now. Let's see, so off should be like that. Let's just match these up here. That should be off. Okay. Let's go ahead and put our brand new Energizer Industrial into it and watch it come back to life. Click. Put our fuse back in. We still have all of this to take care of. Alright. Get some gloves back on, and we'll be back. Okay, welcome back. Well, a long time has elapsed, and we were able to clean these up pretty darn well. The fused one didn't have too much wrong with it, mainly on the outside. The inside was pretty okay. We do still have some staining here towards the top, but it is a lot better than it was, and pretty much every other area is now nice and clean, aside from just a little bit of staining from whatever that was on top. If you can see there, not too bad. The one that was absolutely freaking horrendous has cleaned up pretty nicely. All we did here was just some warm water and detergent, just dish detergent, scrubbing it for absolute, just, you know, huge amount of time here. And Fluke's rubber is pretty nice. It comes pretty nicely and is, you know, look at that. Looks pretty darn good. We got all the rust off of the inside here. We've blown out and cleaned our switch. Still not the absolute best feeling. Just heavily worn, but doesn't feel gritty anymore. So that's pretty okay. We still have a huge spot on our plexiglass here. That is on the outside, it feels like. We did try using, you know, a whole bunch of stuff, oil, just even Goo Gone, and it will not come off. So it's like etched itself into the plastic, I guess. So we're gonna have to try and use some sort of a compound to take that out. Just buff everything down, in other words. Same sort of thing happening here. I don't know what originally happened there. If we wet that, it sort of disappears, right? Until it dries again. So that's a bit strange. It's like eaten out of the face of it itself. Can't really do much better than this right now without getting some special compound to get that out. But I will get some correct foam and put it in here. That way our battery seat's nice and snugly So anyway, back to our unfused unit with our brand new battery inside and our nice clean contacts there. Let's reassemble and, well, get to testing here. We should be able to turn on. We hear a beep while I'm holding it here. Yeah, the switch feels a lot better. Feels like mine. Like a heavily used Gen 1, but just by, blowing it out, essentially. So, we know that everything is all good mechanically here. Got our brand new contacts in, not a speck of rust here anymore. Meter looking real fine. And gotta fix the outside so we can see that better. But I will get the screws back in here, get this back together. There we go, serial nice and visible, rust gone. That's unit 1. Now back over to here, and for now I will be using, because I didn't have a spare Bussmann KTK fuse, so we will use this Gould one. It is a fast-acting 15 amp 600 volt fuse, so it is correct, but it does have a nipple that we do not need. But aside from that, it is also a correct fuse, the correct voltage and amperage rating, so we'll get that in there. And we've got our brand new fuse in there, so we're looking good. We've got our brand new Energizer Industrial. Let's plug it into our new sockets here. Bump. Looking good. Let's get our face on. That unit, the foam is still kind of intact because it didn't get rust all over it, so I'll just leave that. And we'll see here. I'll get its screws back in. Okay, take number 1, unfused. Get it installed. Womp. Yay! How is that for a successful repair that you can't necessarily see that well because we gotta polish the screen still that I didn't do, but we'll do that later. And then we'll also we're going to test calibration with the DMM check there, but we're also going to go hook them up to the Fluke calibrator and just get our final thumbnails and stuff there, ensuring everything is within spec. I like how I did not even cal either of these, and yet they're still, even with this much damage. This one wasn't too damaged internally, just the broken battery connector. That one, however, tons of rust all over its traces and stuff. Just really, really bad, but have a look at that. 2 happy Fluke 77s. Nice and repaired. And see what I mean with the different screen types? How one is blacker than the other? Look at that. And one is very like coppery colored. Very strange. Most of mine, like my 77, is like this. But I do have a few, mainly just one other meter that's like this. Strange. Must have used a different LCD manufacturer or something, or I don't know. But that's them there. And of course, thank you for the peace offering of this or whatever, but I will keep this and we will use it at a different time for something that needs that specific connector, because we had some brand new, the exact right one. So if yours is damaged and needs one, Keystone 593 and Keystone 594 are what you are gonna want. DMM check. R8. .99, yay! Within spec. Now what does this one say? Also 4.99 still? 4.98, you got messed up a little bit. Darn. Okay, I mean, we'll cal that. It's probably when we were cleaning the board so much, and we had to take off both connectors, so obviously our cal got a little bit affected here. But we'll go through our ohms ranges here one more time. This should be the one that was pretty much on cal. Yeah, 1 count low. 1K, perfect. 10K, perfect. 100K, perfect. And just for, we know these leads are pretty garbo, let's not use them. We'll use these leads. Let's see if continuity works. Yep. Nice, back over to ohms here. And we know our cal is now slightly out from the repairs, but was pretty within spec before. Yeah, we're a little bit out now, a little bit low. It's all relative to its own stuff, so we'll adjust that. If we're good, it should be within spec again. Yeah, we're out. And you damn well know I can't leave it there, right? So we're gonna cal it right now. 5. So all we do is adjust this. Looking pretty okay. Let's put the face back on so we can go into AC and see if that's within spec. Switch this over to AC. .55, 5.54. That is within spec there. Let's make sure our ohms ranges are okay. A little high down low because of the probes themselves. None bang on. Okay, I mean that's 2 counts low, still within acceptable range. We'll come back to that, but alas, that is what it is doing. So, let's go ahead and test the milliamp AC range. It should be like 1.11. Still 1.10, that did not change. So 1 count low. Let's check milliamp DC. I believe before it was registering 0.99. Yep, still, well, 1. Yeah, 0.99, 1 milliamp. Now we're looking for 5 volts DC. Yay! Now let's put everything back together. And really this one is still fairly within cal, so all we're going to do here is just bump ever so slightly that adjustment so that we're 4.995. Like it's going to display 4.99, but we want it to ever so slightly be 5. So we're just going to literally tweak it by like nothing. There we go. 5. That's 5. Let's see if we just took out any of the other ranges, or if we're good. AC, yeah, 5.53, still within spec on AC. Let's go ohms range. exactly 100. Within one count on the bottom end there. Perfect on 1,000. Perfect on 10,000. Perfect on 100,000. Nice. Yay! That's all for today. Do they take longer to start up? 1, 2, 3. 1, 2. Yep, yeah, they do take a little bit longer to start up, don't they? They are older. Well, that's all for today. They are cleaned up, new connectors, new batteries, new fuses. They live. We'll come back to this one later, get our cal perfect on the ohms range, try and clean up this and repolish the display so we can see better. But aside from that, they are both fully functional units and technically within spec. These leads are trash and mix matched. This is fine. That's how they came. And that's pretty much all there is for now. We'll edit in hooking them up to the actual calibrator as well as other specs, and that's about it. Thanks for watching.